Okay. And I'm Jen Carter, and I'm joining you here from the traditional unceded territory of the Silk people here in Vernon, BC, which is in the Okanagan, and also beautiful, beautiful, beautiful here, and going to be even more beautiful by the weekend and warm, like almost 30 or something. So anyway, this session, this third session today is going to be focusing on formative assessment of fractions and helping us like gain a deeper understanding of foundational ideas and concepts around fractions, which we've kind of been doing all along, but then also highlighting like common misunderstandings that students may have around fractions. And we've got some of this information from like Marion Small, from resources like First Steps in Math, but also just, I would say probably between Sue and myself, our work with students and things that we commonly see. We want to share some, help you know what to watch for when you're working with students around fractions. And that, I think, from the conversations I have with teachers here, those understandings and misunderstandings happen all the way up into grade 8 and 9, even though it might be like a grade 3 or 4 concept. So really important to have those in the back of your head and have an understanding of those. And then also just helping you understand like what to emphasize to students and what to explicitly teach, because you've probably noticed in our sessions, it is like very visual. We want kids exploring ideas, but there are also things that we need to be explicit about. And then we hope to share a couple of ideas of ways to document those observations that we notice with our students, and then further ways to support students and move their learning forward. So that's what we hope you gain from today. And I think I'm passing it back over to you, Sue.
Yes. So I always like to, I like the slide to remind me it's all good. We're good. I always like to start any talk that I'm doing with teachers about fractions with a fraction talk. I've been going into elementary classrooms over the last couple of weeks working with fractions, and in some of those classes, I'm also starting with fraction talks, and fraction talks is something that I do with my grade 9 class right away at the beginning. And I'll probably talk a little bit more about fraction talks in a moment, but I thought we would do one. I'm going to, if I was doing this in a class, I would give the students very specific instructions, like, I just want you to have a look, and what fraction do you see? And then how do you see it? And ask those students think in their head first, and then just use a thumbs up approach close to their chest so that they can share that they've got a fraction that they might be willing to share, and then give everyone some time to do a pair and share, talk to their neighbors, and then we'll share out. Of course, this is Zoom. It's all a little bit different on Zoom. And so maybe I'll just ask the question, and if you feel comfortable, just throw a fraction into the chat. And then if you could maybe type in how you saw that fraction, we can share some of those things in the chat. Or if you don't mind turning on your camera and your microphone and sharing that out loud as well. So what fraction do you see? How do you see it? Okay, we've got one fraction in the chat. Flona, do you mind sharing your thinking about the quarter that you see?
Yeah, I mean, I just roughly divided the figure in 4 parts, and the yellow part was, it was really obvious. It's difficult to articulate, but if you rearrange the parts, so the yellow, there are two of those darker blues. If you put the one blue below the other blue, that will be another quarter together. Then again, the lighter blues, if you put below the green, that will again be quarter. So if you arrange it in your mind, you can say the yellow one is a quarter. I
So
forgot to
when
mention. Yellow,
when
yeah.
you were describing that, what I saw was like the 4 vertical
Yeah, exactly.
columns.
Yeah, sorry.
Okay.
Vertical columns, and
Yep.
the yellow column stood out as 1/4. Yeah. Yes.
Okay. Nice. Thank you. Anyone else want to share one of their fractions? We've got 2/16. I've got a quarter is purple. A quarter is asking about the portion in yellow. A half for blue. Quarter for green and purple.
Volunteering in one of our elementary schools, and there's a whole pile of Irish teachers and EAs there.
Ooh.
St. Augustine's over on roughly Broadway and Arbutus.
Anyone else want to share thinking there about a fraction before we move on? This is always a little awkward over Zoom.
Yeah.
If I was doing this in a class, I would be writing things on the whiteboard, trying to annotate what students are thinking here. I like this. I did this fraction talk yesterday in a grade 4-5 class that hadn't done any work with fractions yet this year. And so it was interesting because at first they're like, wait, we don't even know what a fraction is. And then it didn't take very long for them to be able to start talking about fractions and seeing different fractions. I think I might carry on to the next one. So I'm going to pass it back to you, Jen.
Okay. Oh, this looks a little bit strange. Yeah, so I also have used fraction talks in grades 3 all the way up through grade 8. And so I'm more, Sue's more talking about the upper grades. I'm going to be talking more about the earlier grades today, like grades 3 to 5. This is one from Fraction Talks, the website that I often use if we're just introducing fractions in grades 3 to 5, depending. Lately I've been coming across kids who feel like they have never encountered fractions before in grade 5. I don't know if it is a COVID thing or they're just not remembering or making the connection. I'm not sure, but so I love fraction talks because I think it's a great tool to use for formative assessment, just to right at the start see what kids have in terms of language, in terms of conceptual understanding. And so just like Sue, I would put up an image like this. I like this one because, and I ask kids, what do you notice? What do you wonder? About the image. I kind of start that way just because I want to start to hear what fraction language they might use. And then we get more into, okay, what fractions do you see? How do you see them? Usually kids right away will say half. And I notice that kids in grade 3, grade 4, they can identify half, but they don't often understand what 1/2 means, that it means 1 of 2 equal parts. So it really sometimes it just comes down to that very basic conceptual understanding of 1 of 2 equal parts of the whole. And so I try to just let them like help emphasize that piece of understanding. And then as they're talking, like Sue said, I like to annotate what they're saying. And so it's really helpful if you can project the image onto a whiteboard, or in some cases in classrooms, if they just have a pull down screen, then I will use my iPad and let kids come up and draw over the image, or I will do that on my iPad so that they can see. Some of the things that I've noticed with kids is that they really need help in especially grades 3 to 5, connecting the language to symbolic and also to the picture. So being really explicit about that is important. Some things that I notice kids will, once they understand what 1/2 means, that it means one of two parts of the whole, then other fractions start to emerge for them. So this is an example of some things that had come up in a fraction talk that I did recently, where kids, after they right away recognize 1/2. We talk about what that one of two actually means. And then right away they can see that purple is 1/4. But then then kids start to maybe like move the orange down underneath the red to talk about how that also the red and orange could make a quarter, or even if they realize that putting red and orange together is 1/4, then half of that, if they're thinking about those parts or those triangles and counting them, they can count that there are 8 of those orange triangles, and then they start getting into understanding about unit fractions and counting to figure out unit fractions. I think
Okay.
that's all I was going to say. I don't know if you want to add anything.
No, well, because I'm going to keep talking about fraction talks in the next slide. So in my grade 9 class, I really wanted like spend the first few weeks, maybe even the first month, getting to know their thinking about fractions before we jump into anything. And so I use fraction talks on a regular basis. And with the fraction talks at that level, I'm really using them for formative assessment. So what is it that my students already know about fractions? What are the supports that we can put in place to help them understand more about fractions? So I might show them this image here and just ask them to estimate like how much of the whole is shaded pink. And so I want to see whether or not students are able to look at that and say, oh yeah, like it's definitely like, even if it's just, oh, maybe it's 1/4, or I think it's less than 1/4. But can they kind of narrow in on how much of the whole this might represent? Are they even willing to put that into words? And then I'll show them another image and I would give them a paper copy at the same time. So I'm going to add in some lines here. The lines that I've added in don't necessarily help us to equally partition the shape into equal pieces, but it gives the students a guideline. And it's amazing how much I can learn just from watching students in grade 9, whether like which are the students who immediately just start to divide up this square into 16 equal pieces, perhaps in this way, and who are the students who have no idea even where to start doing that. So I'm looking for, can they estimate? Can they equally partition this area model? Are they able to name these fractional amounts? Can they count that, oh, there are 16 of these small triangles in the whole square, and 3 of these are shaded pink, and so the fraction is 3/16. Because there's a big difference like in my grade 9 students and their fractional understanding. And then some students might even go further and divide it into 32 equal pieces. So now all of a sudden we can talk about comparing fractions, like what is 3/16 compared to 6/32. Oh, hey, it's the same thing. And we're talking about equivalent fractions without needing any kind of procedure to do that. Also, these fraction talks are really great to really keep track of like, ooh, what are they thinking? Like, ooh, what are the unexpected things that come up in the conversation? So where's that emergent curriculum? And to expose the students to their peers' thinking. So I've been doing some fraction talks in a grade 6-7 class over the last 2 weeks, and I've been in the class 3 times now. And the first time I went in, I had one student who didn't write anything on the paper, but took a bite out of the paper and did the same thing the second week and just handed back a piece of paper with a bite taken out of it without writing anything down. And the third week, the third visit was yesterday, and that student immediately drew like, oh, I can see how I could divide this square into 9 equal pieces, and that square is a 9th. And I thought that student hadn't really engaged in anything over the last 2 visits, and when I saw that, I was like, oh, she's figuring things out based on what we're talking about and what the people at her table have been talking about. And so being able to have the students learn from one another there, and that power of having a routine. Like each day I've gone in, okay, we're going to do a fraction talk. The kids know what to expect. In terms of keeping track of things, so with this formative assessment, say in my grade 9 class, I want to know what it is that I'm looking for. And then I'm just going to like have a checklist. So I've got a list of all my students' names. I've got a couple columns, and I might keep track of information over several weeks, just gaining some more evidence like, oh yeah, okay, so-and-so is able to partition this into equal pieces. And I've seen that 3 times. I think that that student's pretty solid, or I haven't seen this student do that yet. So I know where to pay more attention in terms of providing some support here. I think that's, I'm off to, I'm turning things back over to you, Jen.
Mm-hmm. Okay, something that I spent a lot of time looking at this book, which is in our resources, but Marion Small, I love her like uncomplicating fractions. She has one on algebra, one on proportional reasoning, because I love how they show that progression. And she talks about the importance of starting with language in the earlier grades, as when you start working with kids around fractions, that starting with language first and then connecting to symbolic. And that's where our jobs come in, like when we're needing to be explicit, like explicitly teaching something, helping kids gain that language and then making that connection to either the visuals, but then also the symbolic piece, helping kids make those connections. Kathy Marks Carpan had said in, I forget which one of her resources, that 90% of math language is used only in the math classroom. This is a word explosion that I think we did, I don't know, a couple
Ooh.
years ago, I think.
Northwest,
yeah,
2021.
Yeah. We just asked, like, what are all the words that you can think of that are related to fractions? And there's a lot of language here, and you can see that a lot of it we don't use in our everyday lives. And so having that in mind, being intentional about the use of language, exposing kids to fraction language, and you probably will have to spend some time teaching what this language actually means and connecting it to symbolic.
I just want to jump in here before anything else. And the word fraction is something that students encounter outside of the math classroom, but they encounter it in a different way. And so fraction tends to mean like a little bit of something. Like, hey, can you save me a fraction of that pie? Although I'm not sure I'd ever say that, but you get the gist of that context. And that means just a little bit. But when we talk about fractions in math class, the fractions aren't just a little bit. They can be more than 1. They can be less than 1. They're also very specific. Like we talk about a quarter is a fraction and 2/3 is a fraction. If we're talking about a fraction, we want more information than just a little bit of something. And so this is a new way of thinking for students. And I think, I know as a secondary teacher, I forget how complicated improper fractions are for students, or how like they just don't trust them really, because that's not how they've been thinking about fractions in the real world. And one other thing I wanted to share was I was in a grade 3-4 classroom, and we decided to Google what the fraction bar is called. And it has a name. It's called a vinculum. And then the EA who Googled that for us also went a bit further and said that, oh, this comes from, I think it was a Latin word, which means to bind or to bond. And so that vinculum is binding 2 pieces of information together. And interestingly, the word fraction comes from the Latin fractio, which is a breaking down or a division. And so a fraction is something that's breaking things into pieces, and the vinculum is what is binding these pieces back together again in another way, perhaps. So I just wanted to add that out there. I have also taught English, and so I like to look up the etymology of our math words because I think it adds a little picture of what these words and their meanings are.
Nice.
Next slide.
Next slide, yes. Just there are misconceptions around math language in general, and one thing that I've read in research is about like homonyms that can get in the way of kids' understanding of math language. So you may be saying the word half, but they're in their mind thinking of the word have. That's one example. Marion Small talks about 1/3 versus third. And when we say a third, kids might, especially like grade 3, grade 4, might have in their mind the ordinal number third. So that's something to watch for. And we also have to watch ourselves and the language that we are using when we're teaching. I often hear teachers say 5/8 rather than 5/8 or 5/8. And that 5/8 can lead to a misconception that 5/8 is two separate numbers, a 5 and an 8. That's a common misconception we see with kids. So just, yeah, pay attention to the language, be intentional with it. Make sure when you're teaching, you're being very explicit about teaching what that language actually represents. Okay, and so some of this is also from Marion Small, just some common misconceptions, and she talks about the importance of understanding of half, and starting there, for our curriculum, it's in grade 3, but the idea of half or any fraction is equal area or quantity or partitions, that partitions can be different shapes or sizes, but the amount of each partition is the same related to the whole, and that one half of a quantity is one in each 2 parts. So 1/2 may also be thought of and named as 2/4, 3/6, 4/8. And that idea that the sizes of the shapes are related to the size of the whole. So like the 2 rectangles at the top, both of the blue shaded areas are half of each corresponding whole. So yeah, just some things to help your kids understand. Like I also noticed with kids that they have misunderstandings around sets, and being able to think about like the set of fruit, and half are bananas and half are strawberries. They don't all have to be, even though we often say they have to be equal parts, they have to be exactly equal, but like in a set model, they don't necessarily have to be exactly the same, right?
And kids would see that distinction too. And so I think it's really important to talk about that with the students, not just to make an assumption that they can flip back and forth. I was having a conversation at lunch today, and really when I think of a fraction, if I think of the fraction 1/2, I can picture it in many different ways all at the same time. But my students can't do that. They are just seeing little bits and pieces, and not the whole thing just yet.
Yeah, and so this is also from Marion Small. She talks about providing students with the opportunity to cut and rearrange in order to be able to see, for instance, thirds here. They might not recognize that the square on the right, I hope I made that, hopefully it's accurate, Sue, but that the square on the right, if they were able to cut it apart and rearrange it, they'd be able to see the thirds. So giving kids that opportunity, and that's really important for them to understand that they can rearrange and move parts to determine a fraction. There's a really good Joe Bowler, or a lesson from Joe Bowler, where they're cutting out snowflakes and then they glue all the pieces to the back of the page to determine how much of the page they've cut out, what fraction of the paper. So yeah, just those types of things to help them think more flexibly. And that kind of leads into the next slide, I think. Part of this, like in that resource Beyond Pizzas and Pies, they talk about, or Pizza and Pies, they talk about the importance of kids being exposed to different models: area, set, linear, and volume. This is a diagnostic out of numeracy nets that we use here in Vernon, just as a piece of formative assessment to just initially understand what kids understand or misunderstand about fractions. And they're just basically circling which images show 1/4. And when I use this in grade 5, I would say almost all students are not able to do this properly at the beginning. So there's lots of things here that this uncovers that they don't understand, that they need to be equal parts, that some kids might see, they don't see the set, like think of a fraction of a set because they haven't been exposed to that before. That idea, like in the bottom right-hand corner, that those shaded pieces can be moved in order to see 1/4. So it's a great, quick little formative assessment to just get a base understanding of where they're at. I think that often we, in early years, we as teachers have kids do a lot of like naming and labeling pictures of fractions, but not much playing around with and just all those things that we've talked about so far. And then just talking about equivalent fractions a little bit, Sue and I are both going to talk about this, but I often see in grades 4 and I think grade 5 about equivalent fractions, that idea again, that kids don't understand that they need to be equally partitioned. And that as the number of shaded parts increase, the overall number of parts in the whole increases as well. They don't necessarily know or see that pattern. I think that those were the main 2 things that I've noticed with kids. I know you wanted to talk about with later grades, or no?
Yeah, did you want to talk about this slide at all?
I will after. I'll just talk, yeah.
Okay, so I'll pop into the next slide. So like in grade 9, what I find often is that students really don't see a difference between these 2 statements. That they often, when they're working with equivalent fractions, will write down 2/8 times 2, and then write that as, that's going to be my 4/16. And so one of the things that I think would be really great is for students to really have a good grounding in equivalent fractions without any kind of introduction to a procedure. That the procedure, like if students are introduced to procedures before they have a conceptual understanding of that the parts to whole ratio is being word that is sticking with the equivalent fractions each time, they really won't be able to figure out what the procedure means, like in the end. And so they when they write something like 2/8 times 2, I'm like, are you sure about that? And they're like, yeah, like I've multiplied the both parts by 2, and they really don't have any kind of understanding that if they're talking about multiplication, they're really talking about multiplying it by 1. And that's kind of a complicated idea that they may not need in order to develop that understanding of equivalent fractions. Do you want me to go back to that other slide?
Yeah, just for 1 second.
Sure.
Something that last year when I was working in a couple classrooms that we noticed was that kids needed some choice in materials to use in order to show their understanding. So something that we did was just like provide a basket of random things and some dry erase markers so that they could label on their desks. And we just said, show us what you know about fractions so far. What fractions can you make? What equivalent fractions can you make? Label your thinking and use fraction notation if you can. And then we were able just to walk around and really clearly see where kids were at. And so that choice was motivating to them, and it was also enlightening to us about what we needed to do next. Is this mine?
Yeah, but I think like we're like, talking about that power of observation and how observations are a valid form of assessment, that we can, have students doing tasks with Cuisenaire rods, with all kinds of different materials, and we can be observing what it is that they're thinking as they're drawing things out, writing things down, playing with the materials. We can ask them questions. We can learn more about the math listening to the students. Like like my students teach me things all the time about mathematics and show me different ways of thinking. But the power of having a clipboard and being able to make some little observational notes as you are observing what your students are doing is a really powerful way of assessing where they're at and getting to know where is their understanding, what are they able to do, but also to know what you're looking for ahead of time. That you're like, okay, I'm going to do this task, and here are some things that, and it could be that you're only focusing on one particular piece. Like maybe can the students find different ways of representing the same fraction, and just making some notes. Who can do that? Who can't do that? Maybe it's, can students find equivalent fractions? Do they understand that 3/6 and 1/2 is the same thing? And just making some little notes about who can do that and who can't.
Yeah, and this was an example from grade 6, 7 at one of our schools here in Vernon, and they were just that the purpose was for them to find equivalent fractions, but it became clear almost immediately that half the class didn't understand that there needed to be equal parts. So just asking that one question just led to a 45-minute lesson of just uncovering misconceptions that kept coming up. And it just really, I didn't necessarily have a lesson plan. And I find that often, especially with Cuisinart rods, that misconceptions are revealed very quickly, and then it just drives your whole lesson based on what you're seeing in what students are doing. So
I want to flip ahead to another slide, but now I'm not sure because I know there's a new slide that I'm not sure about. So maybe I'll just keep to the same order.
it might be just a quick
this next one was the splat. Do we want to? It's 404.
Yeah, let's skip that. Fraction splats is really just super powerful. I encourage you to try it. We won't do it today, but if you haven't used it, it just gets to adding unit fractions right away.
Yeah, and you can introduce, like there's nothing wrong with introducing an informal way to add, subtract fractions well before grade 8. Like there's no reason why students can't add these 4 quarters and see that it's a whole well before they start adding fractions in grade 8, but we don't have to assess on that until they're in grade 8. But just building that conceptual understanding, like if all of my grade 9s came in understanding that if we have 4 quarters, we have a whole, then things would be so much easier. There's a lot here.
We as the teacher or facilitator can annotate that symbolically so kids may see it, they may see the equation, but like Sue said, that doesn't mean we have to assess that. This was just a really quick little something else out of Marion Small. She talked about helping kids like understand relationships by using something like pattern blocks, for instance, and having them overlay. So I just threw that in there.
Hey, I'm going to do that test tomorrow with a grade 2 or grade 3, 4 class.
Fun.
Yeah.
Sue was talking about jotting down notes. This is something actually that I used years ago from Daily 5 in literacy. I love this because you can just jot at the top of each box like what you're watching for, not necessarily a strategy, but maybe even just an observation, or maybe it's a misconception that you notice with several students, so you jot it at the top and then you put the students' names down the side, and then you can do your planning of your small groups or whatever for the next day. So it's just a tool that I've always loved in math to help me stay organized with my observations and planning.
And if we look at the triangulation of data, that these 3 pillars of things that we should be considering as we're trying to uncover student thinking, observations is one of
you get it afterwards? I'll give them a quick clean.
3 pieces that we want to consider. And the idea of student choice and student agency, like when we give a test, the students have no agency. they're just doing the questions that we picked out, and they really have no say in the matter whatsoever, but being able to have some conversations and making observations and watching them work through problems is a really, like, I don't know, I think that I learn so much more about my students' thinking when I'm having conversations with them, and when we can do that in the moment, and uncover thinking right away, and just maybe make some shifts rather than, like, testing them and then a couple days later they get the result back and throw it in their backpack, and they're on their merry way. So this was a task. I found this task in the New Zealand math curriculum, which I would strongly recommend that you have a look at. The pages that I've read through recently, just really some really great tasks. So I have done a lot of research on Cuisenaire rods over the past month or two, and this was one of the tasks. And I think I talked about this in one of the previous sessions, but what I really liked about this was that I have this task, but it came along with, here are the things to look for. So here's the list of things, and these comments here, or this bullet list of things to look for, is giving me so much information about what my students already understand or maybe don't understand about fractions. So if we're doing this number line activity, I can see whether or not students are able to equally partition their number line. Can they use the Cuisenaire rods as measuring tools? Can they name unit fractions? Can they find new unit fractions? So are they able to use a measuring tool of 2/3 and then figure out, well, how can I figure out what 1/3 is? Or the 3/5? Can they break that up into 1/5 unit fractions? Are they able to find multiples of a fraction? Can they go beyond one? Can they keep counting and find some other unit fractions, or find multiples of these unit fractions? Are they able to find fractions within fractions? So having that sort of checklist, like, okay, I have an activity here. What is it that I'm looking for? Just make sure that we're on track for observing and making some notes and figuring out what our students are thinking about.
This is just an
you, Jen.
example of a clothesline activity where, and the reason we wanted to put this in was that when you're thinking about number lines or clothesline activities, helping kids connect to different values. I was looking for one with mixed numbers on, but I couldn't find one. But just keeping that in mind, like having kids place these different values on a number line and helping them see the relationships.
So one of the books that Jen and I have based a lot of our presentation on has been the Kathy Bruce Tara Flynn, and I don't have my book with me, I can't remember the third author's name, the Rethinking Fractions book, and they talk about 8 core concepts. And again, they talk about these core concepts, so estimating fractions, equally partitioning unit fraction, or equally partitioning area models, set models, and linear models, naming and counting fractional amounts, composing and decomposing quantities, partitioning unit fractions to make smaller unit fractions, comparing fractions, and then finally the operation. So adding and subtracting fractions is the 7th concept, and multiplying and dividing fractions would be the 8th concept. But the idea is that these aren't necessarily a linear progression, that we really want to be circling through all of these. So here are like some really, simple tasks that let you understand, like, can they estimate? Like, do they have an idea of, like, if I'm looking at the green rectangle that's labeled A, what fraction do they think the green rectangle that's labeled B is? And then, what if the smaller rectangle is 1? What fraction would B be? And so some quick and easy tasks that just allow you to understand where your kids are at with these different concepts. So like it's like, and students need to have experience partitioning the fraction, like the wholes themselves. So you know, fight the urge to always give them shapes that have the partitions already made. Cuisinart rods are really wonderful for that because they can, depending on what hole you're using, you can use your Cuisinart rods to represent any number of different fractions, as opposed to the fraction strips where they have the fractions that are already labeled right on them, so that they're named as, like I saw in somebody's classroom, like, you know, here's 1, here's a half, and those names are attached to the strips. That the kids don't, your students don't then have that opportunity to name fractions themselves or to partition them. So, you know, could they, here's a quick and easy thing I could do with any number of grades, even like, what would you do? How are you going to partition them? Can you find 5, 6? And then looking at a number line, I'm working with a grade 8 teacher tomorrow. She started doing some work on fractions, and she's made a lot of assumptions about what her students know about fractions on a number line. And what she realized is that she realized yesterday or the day before that just because it makes perfect sense to her where a half is between 0 and 1 doesn't necessarily make sense to the students. And so, you know, being able to have some quick and easy tasks to see where they're at, like, could they, if you pointed at a, you know, this dot that's between 0 and 1, what are your students going to say? What do they think that is? Could they figure out how many 2/3 are in 2? Like, such a lovely introduction to division of fractions, and to give some context to that idea of 2 divided by 2/3. Can they find fractions in between 2 fractions? So if you've got a quarter and a 3/4 on a number line, can you figure out a fraction that would be somewhere in between? Can you find 2 fractions somewhere in between? Can you justify what those are? Ooh. Are there more tasks? I think that's it. Do you want to say anything about the tasks, Jen?
Sorry, I can't think of anything else right now.
Okay, that's okay. So really, all of like these tasks that I've just shown you are all very visual. So there's not necessarily any kind of standard algorithm that's associated with these tasks. And if we're going to play with different representations, if we're going to let our students explore number lines, if we're going to encourage the use of Cuisinart rods to help understand fractions, we need to be using the same tools in order to assess them. That we want to be able to say, okay, well, what does a picture look like? And I would say that, you know, for most of my grade 9 students, if they've encountered operations on fractions, me knowing whether, like, if they can multiply 2 fractions with a standard algorithm, I'm not convinced whether or not they understand what it means to multiply those fractions. And so if we start thinking about, like, if I ask them to draw a picture, like, what would 2/3 times 3/5 look like? And they can't draw a picture to show that thinking, then that's where I start to question whether or not they have a really good understanding of multiplication. So I just use these 2 fractions as a starting point. And there's a number of different ways that we could look at multiplying these 2 fractions together using these rectangles. So we've got our 2/3, we've got our it was 2/5, not 3/5. I can't see my entire screen. I'm kind of winging it here. So how could we use these rectangles to model 2/3 times 2/5? And if we were all together in a place where we had whiteboards or paper and pencils, we could start to do this and share with one another what we might think. I've done all the thinking for you. I'm sorry about that. But here we've got our 2/3, and I've colored in, sorry, I've got my 2/5. So what does 2/3 of 2/5 look like compared to 2/5 of 2/3 look like? And we can see that the rectangles themselves look different. The product is the same. We've now partitioned our rectangle into these 15 equal pieces, and we can figure out which of those equal pieces we're looking at. We've got this overlap. So the dark green and the dark orange in both rectangles represents our product, although the light green and the light orange are slightly different representations. Or we could look at this in a different way, and we could say, okay, if our rectangle has a side length of 1, where would 2/5 be? Where would 2/3 be? And think of this as an area model. So what is 2/3 times 2/5? Well, I'm going to shade in the little tiny rectangle that has those 2 side lengths. And so now our blue area, which has the same space as those other 2 rectangles, but is now our 4/15. And this square took me a while, because in this model, I need a square that has side lengths 1. And so I had to play around with the diagram here. It's slightly different from the previous rectangles. But I just wanted to kind of show, like, there are more ways of thinking about multiplication than just, hey, multiply across. Which leads us, I think, to kind of like, we're winding down here. It's 4:19, so we're doing good with the time. And I wanted to share some of the things that I've been learning about why fractions are difficult for students. And so the language. So we've talked about the language already, about how the language can make things difficult. The written notation is difficult for students. So we've, like, up until they're introduced to fractions, students are writing numbers from left to right, just the same way that we're reading. But fractions are written top to bottom. And so the direction changes. There's also, like, 2 pieces, there are 2 numbers within that fraction notation. So 2/3, we see those 2 digits, but it's what's happening when we combine those 2 as a whole number. So the students really struggle with understanding sometimes that 2/3 is just one number. It's not 2 separate numbers, but it's the numerator, or the count, and the denominator and the unit are working together here. Density of fractions is something that is quite challenging for students, really. Like, whole numbers, take any 2 consecutive whole numbers, and there are no whole numbers in between those 2 consecutive whole numbers. So 2, 3, there is no whole number that can be found between the numbers 2 and 3. But we can take any 2 fractions, and we can find another fraction in between. In fact, we can find an infinite number of fractions in between any 2 given fractions. And that, when you start to think about it, is really quite mind-blowing for students. And so this idea of density of fractions is something that is challenging for students. Whole number bias. So students spend a lot of time in their early years working with whole numbers, and they develop some ideas that don't play out necessarily with fractions. Like a product, if we have a product of 2 numbers, it's always going to have a result that is bigger than the original 2 numbers. That works for whole numbers, but it doesn't work always with fractions. And so that is challenging for students. Oh, there's something else about the whole number bias I wanted to remember. Oh, there's new rules for operations. So when we talk about adding numbers, 1 plus 2 is 3, 3 plus 5 is 8, but 1/3 plus 2/5 is not 3/8. So students have this tendency, they want to add across the numerator and add across the denominator, because that's how they've been adding numbers. But it doesn't work anymore for addition, but it works for multiplication. And then it doesn't work for division unless you teach your students that you can divide across the numerator and divide across the denominator. So there's all these rules that they've been learning about that don't quite work in the same way with fractions. And that's something that we have to remember to think about when we're working with our students. Fractions,
and that's why we want it
many...
to be
Oh.
visual, so they can see what's happening. Yeah. And why those things don't work.
And fractions have many meanings. Like, we can talk about the part of a whole. We can talk about the, portion of a set, which may have different meanings, like the strawberries and the bananas. There were 3 strawberries and 3 bananas, so half of the fruit was bananas, but they didn't have the same size. But then we move into a square and we have pieces, and those, in order to be able to talk about a part of the whole, we've got to be thinking about equal size pieces. A fraction represents a quotient of 2 integers. So it actually is an operation. We can divide the numerator by the denominator. And for me, that's just, I know this. I can see all 3 of those meanings at the same time, but the students don't. A fraction can be a scale factor. So something might be half as big as something else, or 3 halves as big. We can have, it's part of a continuous measure. So I can map out the distance between me and the door. I can figure out where half of that distance is. What if I needed to go halfway? And these are all different ways of thinking about fractions that, as adults, as math teachers, as people who have lots of experience with fractions, that might make a lot of sense to us. And we may not see those differences, but we need to remember that students see these as different things, and they don't automatically make a connection between all of these different meanings.
I think that makes it kind of hard to think about teaching fractions just as a unit of study. And that maybe we need to be noticing and naming and nurturing the learning of fractions all year long in different contexts, in their everyday lives, out on the playground, in the gym, like wherever we see it, right?
Yeah, and this kind of leads us to our last slide, which is just this lovely quote from Kathy Bruce, Tara Flynn, and Shelley Yearly book.
Oh yeah, Shelley.
About fractions are spatial. Like, if we teach fractions from a spatial perspective, well, it's really good for kids to learn spatial thinking, and to be exposed to thinking about things spatially. But it's going to make all of these things that are hard about fractions easier for students to understand.
Yay, we did it with 5 minutes left.
We did. That's it. That's like our 3rd session, fractions. Does anyone have any questions?
If anyone has questions or comments or things you've noticed in your students, any misunderstandings that you commonly see that we didn't talk about, it would be great to just unmute and share.
Or if there's anything you'd like to see next, like what did we miss? What were you hoping that we might talk about that we didn't talk about? Jen and I have done a number of presentations on fractions, and I've learned so much, and it's been a lot of fun, and I'd love to do some more.
Well, we in fact are doing more on Monday. Sorry, go ahead, Elena.
I'm just asking, what I find very interesting, or what I've struggled with this year, is kids coming into like grade 5 who already know how to create equivalent fractions just by multiplying the numerator and denominator by the same thing. And I'm having a hard time pushing for the why and how that works. Why does that work? And they come already with, whether it's Kumon or whatever, but they come with those formulas and those operations. They can't really be bothered with the why. And I feel like we're like missing the steps behind, and how I did fraction talks, which I think really helped. And so I'm just finding the resistance to back it up and prove and justify their thinking is really there when they've already been told or taught by someone, home, wherever, but this is what you do. You just multiply. Why? Because it works. And I'm wondering if there's any suggestions for like working with kids that are just sort of resistant to proving, justifying, show me you know, in another way besides just showing me you know how to do the calculation.
So this happened in a school here in that I work with around 2-digit by 2-digit subtraction. They knew the algorithm, they were doing the algorithm wrong. And so when you can find ways that they can play with it visually, like I think Sue mentioned, or maybe we talked about it in one of the other sessions, like the paper folding task to create equivalent fractions and having them label. And like, yeah, we want kids to be using those competencies like justifying and that. But I think if it were me, I would be comfortable if I saw that my kids were playing with the meaning of it. Maybe they're resistant to justifying on paper or justifying in words, but if they're playing with the meaning of it, I think I would feel okay. I don't know if you have anything to add to that, Sue.
Well, I was thinking, like, I see this all the time, like in grade 9. So like I had a student a few years ago, and she did Kumon for years before they moved to Salt Spring, and she knew the procedures. She knew how to add it, but as soon as anything went off the beaten track, couldn't do it, right? Isn't able to, doesn't have that flexible thinking. I did a workshop with high school teachers recently on Cuisinart rods, and we kind of just, like, I brought them out and we played. And I was worried that there was going to be some resistance because they're teachers that I've worked with for a long time. I've had conversations about manipulatives and how they think, like, I was worried that there was going to be some pushback thinking like, hey, like, why would I be using manipulatives in high school? It's too babyish. It's not sophisticated enough. And I didn't get any of that pushback. And what they found was, like, they were able to push their own thinking. And so we started, like I said, oh yeah, we could use these Cuisinart rods to do some multiplying. And all I know is we could do it like this. Like, I could sort of like threw a little bit out there, and all of a sudden, like the one guy who's, he's quite smart and doesn't mind sharing that information with everyone, was like, he's like, oh, wait a second, and he got right into it. So I think the Cuisinart rods are brilliant, and they allow for students to play and explore, and then be exposed to some of these ideas without it being like, but I just did it. Like, I can show you that 1/2 and 2/4, like, I know 1/2 and 2/4 are the same thing, but give them different opportunities for those things to come up with,
I like
I
that.
guess.
Thank you.
But yeah, I am a huge fan of Cuisinart rods.
Mhm. I don't see any other comments really.
No.
All right, everyone. So like Sue said, the recording will be up and the slides, I guess.
Yep,
In a
I'll
week or
put the
so.
slides up over the next couple of days. It does take a little bit of time to get the recording organized. I'm going to stop sharing, and I'm going to stop recording.